All right, Christian, we're back. I promise this is the final video, and there will be no match lighting because I think we're all out of matches. But if you remember where we were, we just found the grams of oxygen. I hope we got that far, right? By subtracting the mass of carbon and the mass of hydrogen from the mass of the whole compound. So now that we have the grams of carbon, we can go ahead and find the moles of carbon, or oxygen, excuse me. And the way we find the moles of oxygen is by dividing by 16, which is the atomic mass of oxygen. So you can see there we have the moles of oxygen, okay? And so now what we did is we just rewrote. We've had our moles of carbon up here, our moles of hydrogen here, and our moles of oxygen. We divide each of these numbers by the smallest number of moles, which is carbon. And so that'll give us 1, obviously, for carbon. It gives us about 1.33 for the hydrogen, and it gives us 1 for the oxygen. So if I were to write the formula right now, it would be C1H1.33O1. And since you know you can't have 1.33 atoms of hydrogen, we have to find a whole number that we can multiply that by that will give us a whole number. So if you try 2, it only gives you 2.66. If you try 3, it gives you 3.99, which is close enough to 4 that we can round it. So we're going to have to multiply all these subscripts by 1 in order to remove that, or excuse me, by 3 in order to remove the decimal. So our empirical formula will be C3H4O3. So now we have the empirical formula. Tomorrow I'll be showing you what you do to get the molecular formula, which is exactly the same thing you did with the percent data. Hope to see you soon. Let me know if you have any questions. Bye-bye.